Before watching this video, you should first of all have watched the Maths Genie video on product wolf accounting, which you can access from this link. Just thinking about the last example in the Maths Genie video, we had 12 girls and 11 boys. If we chose one girl and one boy, we were choosing from different pots, the girl pot and the boy pot. So that meant there were no duplicates, so we simply multiply. I've got 12 girls to choose from and 11 boys to choose from. However, for the second part of the question, because we were choosing two boys, they were coming from the same pot, just the boys. So I had 11 boys to choose from on the first pick and then 10 to choose from the second pick. But because I was choosing from the same pot, I was going to get duplicates that I needed to remove. So that's why we needed to divide by 2. So the product rule of accounting states that if there are m ways to do one thing and n ways to do another, there are m times n ways of doing both. So look at this very basic example. I've got 7 t-shirts and 5 skirts. I choose 1 t-shirt and 1 skirt to make an outfit. How many outfits can I choose? So we're selecting from different pots here, i.e. t-shirts and skirts. So I simply multiply together. Okay, different pots. No duplicates, no need to divide, so I just get 7 times 5, which is 35 outfits. A similar example, but worded slightly differently. I've got 8 starters and X main courses to choose from. Carla says there are 49 possible combinations of starters and mains. Is she correct? So first of all, we need to think about the fact they're from different pots, the pot of starters and the pot of mains. Okay, because there are different pots, there are going to be no duplicates, therefore we don't need to divide. So that would mean that my 8 starters times my X main courses would give me the number of combinations. So my number of main courses would be 49 divided by 8. Now we can see that's not going to give us a whole number, therefore that Carla can't be correct because we need a whole number of main courses. So we can write a conclusion, no, not correct, as X must be a whole number. Okay, so looking at example 3, this time we've got 17 girls in a choir and we're going to choose 2 to sing in a duet. And how many different pairs can be chosen? So here we're selecting from the same pot, just like when we chose the 2 boys earlier on. So we're going to multiply and we're going to need to divide to remove the duplicate pairs. But I just want to stress another point here, which we didn't really think about before. But when we choose these 2 girls, the order we choose them in doesn't matter. So that means that G1, G2, girl 1, girl 2 is going to give me the same duet or the same pair as girl 2, girl 1. Okay, which is why we need to do that dividing to remove the duplicates. So we'll have a choice of 17 girls when we choose the first girl, and then we've got 16 left when we choose the second girl, and we're going to have to divide by 2 to remove the duplicates, so we get a possible number of pairs of 136. Okay, so I just want to stress here again, and I'd like you to write this down, when we're selecting items, girls in this case, and means the order doesn't matter, and the order doesn't matter, that's when we need to divide to remove duplicates. Okay, so let's have a look at an example now where the order does matter. So this is a past practice exam question. So I've got 95 girls and 87 boys, and we're going to choose a head girl and deputy and a head boy and deputy, and we want to know how many ways this can be done. So if we just think about the girls to start with, we're choosing 2 girls from the same pot, but this time the order does matter as they're going into different roles or different positions. Okay, so if we've got girl 1 is head girl and girl 2 is deputy, that's not the same as the other way around. Girl 2 is head and girl 1 is deputy. So we're not going to divide by 2 because we don't have any duplicates. When I do this question, I'm just going to draw some boxes because this is what we'll be doing leading into next lesson. It helps show you the positions that we're going into. So I've got head girl and then deputy head girl, and then I'm going to choose head boy and deputy head boy. So for head girl I've got 95 girls to choose from. For deputy that leaves me with 94 to choose from. For head boy I've got 87 boys to choose from, leaving me 86 boys to choose from for my deputy head boy. Now if we multiply those together we're going to get an awful lot of possible combinations. So putting that in the calculator, that's actually going to give us, I'm going to write it underneath, so we've got there 66,814,260 possible combinations of head boy and head girl. So if we think about it, what we've done here is we're actually arranging the girls and the boys into specific positions. Okay, so in this case order does matter. So when order does matter, we don't divide as there are no duplicates. Again, can we write down what we've got in red there? Right, one last thing just to think about before you have some practice. Just like probability, when we're thinking and, we are multiplying, and that's what we've been doing so far. Head girl and deputy head girl, we've been multiplying. When we say to ourselves or, we are adding. Okay, so if we just look at this question, we've got 5 pairs of trousers, 3 skirts, 8 t-shirts and 2 hats. And I want to wear one of the following combinations. So if we just work our way through them, how many combinations of skirt and t-shirt have we got? Well, 3 skirts and 8 t-shirts. It's different pots, so I don't need to divide, so that's 24 combinations. For trousers and t-shirt, I've got a choice of 5 trousers and 8 t-shirts. Different pots, don't divide, so that's going to give me 40 combinations. Trousers, t-shirt and a hat, so 5 trousers, 8 t-shirts and 2 hats, different pots, don't need to divide, so that gives me 80 possible combinations. So I could have, if we call this combination 1, combination 2, combination 3, I could have 24 skirt and t-shirts, or 40 trousers and t-shirt, or trousers, t-shirt and hats is 80. So if I add them all up, I've got 144 different possible combinations, and these adds here came from the fact that I'm using the word or. Right, to have a practice at these, I'd like you to do, there are 2 different worksheets. I want you to start on the product rule for counting, the Maths Genie questions, and if you finish those and have time, you can move on to the Just Maths number combinations, that H stands for higher questions.